Hello students, I am Snigdha Roy from Parul Academy. Today we are discussing about growth models of ecology. Growth of a population with time shows specific pattern. It is essential to be curious if different animal populations in nature behave the same way humans do. Perhaps we can learn from nature on how to control population growth. Exponential growth. Resource, food and space availability is obviously essential for the unimpeded growth of a population. Ideally, when resources in the habitat are unlimited, each species has the ability to realize fully its innate potential to grow in number. If in a population of size n, the birth rates, not total number but per capita births, are represented as B and death rates, again per capita death rates as D, then the increase or decrease in n during a unit time period T dn by dt will be dn by dt equal to b minus d into n. Let b minus d equal to r, then dn by dt equal to rn. The r in this equation is called the intrinsic rate of natural increase and is a very important parameter chosen for assessing impacts of any biotic or abiotic factor on population growth. The above equation describes the exponential or geometric growth pattern of a population and results in a J-shaped curve when we plot n in relation to time. If you are familiar with basic calculus, you can derive the integral of the exponential growth equation as n equal to n0 ERT, where n equal to population density after time t. N0 is population density at time 0. R is intrinsic rate of natural increase. E is the base of natural logarithms 2.71828. Any species growing exponentially under unlimited resource condition can reach enormous population densities in a short time. Logistic growth. In nature, a given habitat has enough resources to support a maximum possible number, beyond which no further growth is possible. This limit is called as nature's carrying capacity, K, for that species in that habitat. A population growing in a habitat with limited resources show initially a lag phase, followed by phases of acceleration and deceleration, and finally an asymptote when the population density reaches the carrying capacity. A plot of n in relation of time t results in a sigmoid curve. This type of population growth is called Verhulst-Pearl logistic growth and is described by the following equation: dn by dt equal to rn k minus n by k, where n is population density at time t, r equal to intrinsic rate of natural increase, k is carrying capacity. Since resources for growth for most animal populations are finite and become limiting sooner or later, the logistic growth model is considered a more realistic one. In this video, we learned about growth model. We will meet next day with another topic.